Today's video will take you inside the simplest question that turns out to be the most dangerous, one you can ask in science. What's between two magnets? And why do you feel that pull in your hand? This presentation is in a voice and style inspired by Richard Feynman, and it's going to show you how that innocent question exposes the difference between real understanding and the kind of explanation that only sounds good. We'll move fast through several angles you usually never see connected in one place. The trap of comforting analogies. The field is something you can treat as physically real. The hidden cooperation inside iron that makes magnetism loud enough to notice. And the strange quantum picture where empty space is not as empty as you think. I'm reacting to a familiar moment every teacher lives through sooner or later. Someone leaning in and asking for a neat story, and thinking a neat story is the same as truth. If you follow this, you won't just learn about magnets. You'll learn how to think without lying to yourself. Now let's start exactly where the trouble begins, with that urge to demand a picture that nature never promised to give you. I can still see the two magnets in my hands, and I can still hear the question the way people always ask it, like there must be a tidy little object hiding in the air that I'm refusing to name. What's between them? You feel it before you can describe it. Bring like poles together, and your hands have to work to keep them from sliding apart. Flip one magnet, and suddenly it's as if the space between them has a mind of its own, tugging them together. That sensation is so immediate that the brain invents a story to match it. A spring, a rope, a pressure, something familiar. But the first honest thing to say is this: the space between them is not empty. If you insist it must be empty because you can't see anything, you are letting your eyes run your philosophy. The space is filled with a magnetic field, and the field is not just a drawing we make in a notebook. It carries energy. It pushes and pulls on charges and currents. It has a structure you can map and measure. And if you don't like the word field, fine, call it whatever you want, but you do not get to erase it just because your common sense doesn't know what to do with it. Now, since people love to play the game of what if, let me try it in a way that actually teaches something. Imagine 3 alternate worlds, all starting from the same stubborn little question, and each ending in a different kind of understanding. In the first world, we never learn to take the field seriously. We keep the old habit of thinking forces act directly from object to object, across empty space, like invisible hands reaching out. The mathematics still works for practical things, if you're clever enough, but it has a rotten smell in the middle. Where is the energy when you pull the magnets apart? Where does it go when they snap together? In that world, you can build a motor, sure, but when you try to think deeply, you always hit the same wall. You can't locate anything in the space between. So you start inventing invisible gears in the air. You end up with an encyclopedia of made-up mechanisms that only exist to protect your prejudice that nothing is there. That world is full of people who are confident and wrong. They can calculate, but they can't explain without cheating, because they refuse to admit the simple truth that nature has a thing in the space, not just a relationship between 2 chunks of metal. The tragedy is not that they lack a metaphor. The tragedy is that they don't know what counts as an explanation. They confuse sounds familiar with is true. In the second world, somebody like Faraday never comes along with that odd, stubborn habit of looking at patterns and saying, no, the pattern is the reality. Without that way of thinking, you lose a whole style of imagination. The great insight is not the iron filings on paper. Anybody can sprinkle filings. The insight is to look at the shape they make and say, the space itself has a condition. It's doing something. The filings are not showing you a picture of the magnet. They're revealing the structure of the space around it. If that mental move never becomes respectable, then Maxwell never gets the same kind of grip on the problem. The unification of electricity and magnetism arrives late, like a letter delivered to the wrong address. And when it finally comes, it feels like a trick rather than a revelation. In that world, the modern technological civilization you take for granted is delayed not by a lack of intelligence, but by a lack of taste. People never learn to love the right kind of abstraction. They keep demanding a mechanism, the way a child demands a bedtime story. In the third world, we do get the field, and we do get the unification, But we never make peace with the idea that explanations have levels and stopping points. So when someone asks, "What's between the magnets?" we answer, "A field." And then the next person says, "Yes, but what is the field made of?" And then we panic. We feel cornered, so we invent substance again. We treat the field like a material jelly that sloshes around. We act as if naming a deeper layer automatically means understanding, as if the universe owes us an infinite staircase of familiar pictures. That world becomes vulnerable to nonsense because it mistakes reduction for clarity. But the truth is, sometimes the most adult answer is, at this level, the field is the thing. It is the simplest, most accurate description we have, and it earns its keep because it predicts and it measures and it stores energy in a way you can't hand-wave away. Here's the best-case scenario, the one I actually want. A world where we teach people early that curiosity is not the same as demanding a comforting story. We teach them that you can have multiple true descriptions of the same phenomenon, each useful for a different purpose. If you want to build, you use the field equations and you calculate forces and energies. If you want to understand materials, you talk about spins lining up, domains forming, and why certain solids amplify tiny magnetic moments into something your hand can feel. If you want to understand the deepest bookkeeping, you talk about how interactions are computed in quantum theory, without turning that computation into a cartoon of little particles behaving like bullets. And if you want the philosophical lesson, you stop pretending that why always means in terms of something more familiar. Sometimes why means what are the rules? And the answer is that the electromagnetic interaction is one of the rules. So let me ask you a sharper question than what's between the magnets? When you say you want an explanation, what kind of satisfaction are you actually chasing? Prediction, mechanism, or comfort? If you can name that honestly, then we can choose the right level of story and make it real. And if you think you've got a better way to phrase the question, share it with someone sharp and see if it survives the conversation. If you can answer that question for yourself, prediction, mechanism, or comfort, then suddenly the whole problem becomes less like arguing in the dark and more like choosing the right tool from a drawer. And the funny thing is, once you choose the tool, the mystery doesn't disappear. It becomes sharper, more precise, more interesting. So here's a what if that I can't stop thinking about. What if we taught science the way nature actually behaves, instead of the way our nervous system wishes it behaved? I don't mean cramming more formulas into people's heads. I mean teaching the structure of explanation itself. Teaching that some questions are malformed, not because they're stupid, but because they smuggle in an expectation that the universe never agreed to satisfy. Teaching that between is not a blank, that a field is not a polite word for ignorance, and that you can hold several true descriptions of the same thing without feeling like you're betraying reality. In that best-case world, a kid plays with magnets and learns something radical early. You can't bully nature into telling you a bedtime story. You can only ask questions that the world can answer cleanly. And when the answers get strange, you don't patch them with familiar pictures. You learn new pictures. Now let me show you how that would fork history. Because history is just people's habits made solid. In one timeline, the field idea becomes culturally normal much earlier. Not just in physics, but in how people think. Newspapers stop treating invisible forces as magic and start treating space as something with properties. Engineers stop speaking as if wires carry electricity, like water in a pipe, and start speaking in terms of potentials and fields and energy flow in space. It sounds like a small change, but it rewires the imagination of a whole society. In that world, when someone asks, "What's between the magnets?" the answer they've heard since childhood is the same kind of thing that's between a radio antenna and your ear. Something real, even if you can't see it. So when the next question comes, where's the energy stored? People don't panic. They point to the field. They understand that the space is part of the physical system, not a stage on which the system performs. And because the public imagination accepts fields as real, a lot of nonsense loses its oxygen. The cheap mysticism that thrives on invisible forces gets starved because invisibility no longer means supernatural. It just means your eyes are a narrow instrument. Now, in another timeline, the same cultural shift happens, but it goes too far. People fall in love with the word field The way some people fall in love with a new religion. They start calling everything a field. The field of money, the field of thought, the field of good vibes. And then they do something dangerous. They stop asking what can be measured. They stop asking what predicts. They use scientific language as perfume. That's not progress. That's just costume. In that timeline, the magnets become a gateway drug for bad thinking. People start claiming they can heal you by aligning your field, because the real lesson never landed. The lesson was not there's an invisible thing. The lesson was there's a real thing with rules, and the rules can be checked. So the best case isn't teach fields. The best case is teach the discipline that comes with fields. Here's a third fork, and this one is my favorite because it's the most human. What if we taught the levels of explanation explicitly? Like a map you carry around in your head. You hold the magnets. Level 1, phenomenology. They attract or repel. Level 2, classical field. There's a magnetic field in space with energy density and stress that can be calculated. Level 3, material origin. In iron, lots of tiny magnetic moments line up in domains, and defects pin them, so the magnet stays magnetized. Level 4, the deep accounting. Interactions are computed in quantum theory with a scheme that, when done carefully, matches experiments with embarrassing precision. In that world, when someone asks for the real explanation, you can ask them, which level do you want, and what are you trying to accomplish? And people don't feel insulted by the question. They feel respected because you're not dodging, you're choosing. Now imagine how education changes if that map is standard. Students stop memorizing facts as if they're collectibles. They learn how a concept migrates from one level to another. They learn that the same magnet can be a story about domains in a solid, or a story about fields in space, or a story about symmetries and interactions, depending on what you're doing. And then, something sneaky happens. People become harder to fool. Because the moment someone tries to sell them a metaphor pretending to be a mechanism, they can smell it. The moment someone offers a comforting analogy that loops back on itself, they can catch the circularity. They start asking better questions at dinner tables, in classrooms, in boardrooms. What would I measure? What would change my mind? What level is this claim operating on? That's the best case scenario I care about. Not a world where everybody knows electrodynamics. A world where people know the difference between understanding and naming. So let me push you forward toward the deeper part of the magnet story, because this is where the between question becomes genuinely wild without turning into fantasy. If the field is real and stores energy, then empty space is not a passive nothing. If you take that idea seriously, you start noticing that the vacuum itself has a kind of restlessness, not in the poetic sense, but in the sense that the best theory we have won't let it be perfectly still. And once you start thinking that way, the magnets in your hands stop being a toy and start being a doorway, not to mysticism, to a universe where the simplest objects demand that you respect the structure of explanation. If this way of thinking clicks for you, don't keep it private. Hand the question to someone smart and see what they do with it. The quality of their answer will tell you a lot about the quality of their thinking, and the quality of your own question will get better the moment it has to survive another mind. The moment you accept that the space between the magnets is part of the physical system, you inherit a second, stranger idea, whether you like it or not. Empty space is not a dead stage. People hear that and immediately run to poetry, but I mean it in the plain, technical sense. If the field is real, and if energy can sit in a region of space, then you have to stop talking about nothing as if it is a simple object. You begin to suspect that nothing is a complicated thing we invented to comfort ourselves. Now here's a what if that follows naturally from that suspicion. What if our civilization had learned early on to treat the vacuum as a physical environment with rules, instead of a void that only matters when you put something inside it? In the best timeline, the public imagination grows up with the idea that there is a lowest state of affairs, but it is not an inert one. Not because the universe is haunted, but because the bookkeeping of nature does not permit perfect stillness in the way a classical mind wants. In that world, people don't find it scandalous that tiny effects exist and can be measured. They find it thrilling that the world is consistent enough for us to notice them. So consider how history bends when a culture respects small effects. One branch of history becomes a society that is unusually good at precision. Instruments improve faster because the philosophy behind measurement is widely understood. When you tell an engineer, there are subtle shifts in atomic energy levels you can't explain by old calculations. They don't shrug. They sharpen their tools. They look for the missing pieces in the theory. They become comfortable living at the edge of what can be detected. That is a best-case world where the magnet isn't a parlor trick. It becomes a gateway into a discipline of thought. Never confuse the size of an effect with the importance of an effect. Tiny discrepancies are where revolutions start. A small difference between prediction and measurement is not an inconvenience. It's a clue. Now imagine the practical consequences. In that timeline, technologies built on magnetic fields and quantum behavior arrive earlier and more cleanly because people stop fighting the concepts. The language of fields and potentials becomes normal conversation among capable laypeople. They don't need to derive equations. They just need the mental model that space has structure and the rules can be tested. But there's a darker fork, too, and it always appears when you hand people a strange truth without the discipline that makes it safe. In that timeline, the vacuum isn't empty, turns into a slogan. It becomes a permission slip for anything. People start treating quantum as a synonym for mysterious, and then they use mystery as a substitute for evidence. They tell you magnets prove thoughts can influence reality at a distance. They decorate nonsense with technical words the way a con artist wears a suit. That world is not merely silly. It is dangerous because it trains people to stop asking what would falsify a claim. It trains them to accept emotional satisfaction as proof. And if you want to understand why that matters, you don't need a laboratory. You only need to look at how quickly bad ideas spread when they're dressed like science. So the best case requires a second lesson. The universe can be stranger than you imagine and still be absolutely unforgiving about evidence. Now let's return to the magnets in your hands, because I promised you this wouldn't float away into abstraction. When you bring the magnets close, you are shaping the field in the space between them. In a classical description, you can talk about field strength and energy density. You can calculate how the energy changes as you move them and how that change shows up as a force. That alone is already a complete, honest story for most human purposes. But if you keep going, you discover that the deepest description we have of electromagnetic interaction does not treat forces like invisible springs. It treats them as an interaction with rules so strict that, when you compute carefully, the numbers match the real world to an absurd degree of accuracy. That is not the kind of success you get from a metaphor. It's the kind of success you get from touching something fundamental. Here is the what if that makes my skin tingle a little, even after all these years of thinking about physics. What if we taught people to recognize the difference between a picture and a computation? A picture is what your brain uses to feel satisfied. A computation is what nature answers to. The two can overlap, but they are not the same thing. In the best case, we teach that you may not get a comfortable picture, and you should not demand one. You should demand consistency, testability, and clarity about what you mean. If that attitude became common, the whole conversation about magnets would change. People would stop asking for the real explanation, as if there is only one. They would start asking, which description helps me do the thing I want to do, and which description keeps me honest about what I actually know? And then, almost without noticing, the question, what's between the magnets, turns into a better question. What is the simplest story that predicts what my hands feel? And what deeper story explains why that prediction works so well? Because once you ask it that way, you're not begging for comfort anymore. You're entering a partnership with reality. And that partnership has a strange reward. The more you stop demanding that the universe feel familiar, the more it begins to make sense. Talk about this with someone who thinks they already know. Not to win an argument, to watch what happens when their intuition collides with the idea that nothing is not as empty as it sounds. The way they react will tell you whether they want understanding or whether they only want a story that feels good. Here's the strangest part. Once you stop demanding that the universe feel familiar, you start noticing how often people confuse familiarity with truth in every other corner of life. That's where this little magnet question ends up, whether you intended it or not. It begins in your hands and ends in your habits. So let me gather the threads, not by repeating them, but by showing you what they add up to in the best-case world I keep pointing at. In that world, when someone says, "Explain what's between the magnets," they aren't asking for a comforting picture. They're asking for a clean chain of reasoning, the kind that can survive contact with reality. They've learned early that a good explanation is not one that feels good. It's one that doesn't break when you lean on it. That changes everything. It changes how we teach. Instead of training students to hunt for the one right story, we train them to recognize levels of description and to be explicit about what problem they're solving. Prediction, design, deep structure, philosophical clarity. And we train them to respect the boundary between what can be computed and what can only be imagined. It changes how we build. Engineers stop treating space like a passive backdrop and start treating it as part of the machine, because it is. You don't just move a magnet through nothing. You reshape a field. You move energy around. You create stresses in space that show up as forces in metal and motion in machines. Suddenly, the language of fields is not academic. It's practical. It changes how we argue. People stop fighting over whose metaphor is prettier and start asking, what would I measure? What would I predict? What would change my mind? The tone of conversation shifts from performance to inquiry. And if you think I'm exaggerating, just imagine a society where that habit is common. How many arguments die immediately because nobody can hide behind vague words? Now, let's come back to the alternate histories, because they weren't just entertainment. They were warnings. There was the world that refused fields and ended up inventing invisible gears in the air. That world could calculate, but it could never locate energy honestly. So it had to keep making up mechanisms to protect a mistaken intuition about emptiness. There was the world that worshipped fields as a new kind of magic word. That world learned the vocabulary and lost the discipline. It became easy prey for anybody selling mystery as truth. And there was the best world, the one that learned to carry the map of explanation and to use it. That world didn't become less wondrous. It became more exact. The wonder got sharper because it was attached to something you could check. Here's the punchline I want you to feel, because it's the most practical thing I know how to say about physics. Reality is not obligated to be reducible into whatever your childhood found comforting. The magnets don't care if you prefer rubber bands. The field doesn't care if you can picture it. The deeper theory doesn't care if your intuition wants little pellets flying back and forth. The only thing that matters is whether you can state rules clearly and whether the world agrees when you test them. And that's why I love the magnet question, even when it annoys people. It's a small, harmless situation where you can practice intellectual honesty without paying a big price. You can catch yourself in the act of wanting a story that makes you feel in control. You can notice the moment you demand familiarity, and you can decide to do something harder and better. Accept the rules as they are and learn them. Now, if you want a final what if, here's mine. What if we treated intellectual honesty as a civic virtue? Imagine a culture where it's normal to say, "I don't know," without losing status. Where it's normal to ask, "At what level are we explaining this?" instead of pretending all questions are the same kind. Where it's normal to reject pretty nonsense, even when it's comforting. In that world, science isn't a separate subject. It's a style of thinking that leaks into everything. Medicine, policy, business, relationships. Not because equations run your life, but because the discipline of not fooling yourself runs your life. That's the best-case consequence of two magnets on a table. It isn't that everyone becomes a physicist. It's that more people become harder to trick, including by their own brains. So here's what I'd like you to do with this, because ideas don't matter if they stay trapped in one skull. Take the simplest version of the question and try it on a few people who think differently than you. Not as a test of intelligence, but as a test of habits. Ask them what they think is between the magnets, and then listen for what they reach for first. Do they reach for a metaphor, a computation, or a confession of uncertainty? Do they ask what you mean by between? Do they try to impress you? Do they try to be accurate? Then ask yourself the same thing, because you're not exempt. What do you reach for when you don't understand something? A picture that soothes you, or a method that can survive being wrong? If you can train that reflex on a small, friendly mystery like magnetism. You can train it on bigger mysteries too. And that, to me, is the real force in the space between the magnets. Not just a field in the physical sense, but a chance to practice the kind of thinking that makes you worthy of living in a universe this strange. Dramatized closing monologue. I keep coming back to the same small scene. 2 magnets in my hands, and that stubborn feeling in the air that seems to push or pull as if the space itself has a mood. It's such a simple setup that you'd think it ought to have a simple answer. And yet it's exactly the kind of simplicity that tricks us, because it invites us to swap honesty for comfort. If you take anything from this, let it be this strange, practical lesson. The world doesn't need your favorite picture in order to work. It doesn't need to feel familiar. It only needs to be consistent. And that is both humbling and liberating. Humbling, because it means the universe is under no obligation to match the stories we grew up with. Liberating, because it means you can stop pretending. You can stop decorating ignorance with confident words. You can just look straight at the mystery and ask the cleanest question you can manage. That's why I love this topic. It's not really about magnets. It's about the habit of mind you bring to everything else. When someone demands an explanation, do they mean a prediction they can trust, a mechanism they can build with, or a story that makes them feel safe? Those are not the same. Mixing them up is how people get fooled. And the worst part is that we usually fool ourselves first. There's a quiet kind of courage in saying, here's what I can explain, here's what I can calculate, and here's where the explanation stops being a familiar picture and becomes a rule of nature. If you can practice that courage with something as harmless as a magnet, you can practice it with bigger questions, the ones that actually matter, the ones that shape decisions, beliefs, and entire lives. So I'll leave you with a challenge that's more useful than any clever metaphor. The next time you meet a mystery, don't rush to fill the gap with something that sounds good. Pause and ask what kind of answer you're really seeking, and what would actually convince you. I want to hear how you think about this. So drop a comment and argue with each other respectfully. One direct question for you. What's one everyday, obvious thing you've never truly questioned, but now want to? Thanks for watching. If you enjoyed this video, hit that like button, subscribe to our channel, and turn on notifications to stay updated on our uploads. And now, honestly, go find a magnet and feel that invisible firmness in the space, and just sit with the fact that it's real. That still makes my head light up.